This video is going to be about using the wireless modules with the SBS-8400, SBS-4815, and SBS-200CT. In order to remotely monitor the voltages of the cells or batteries with any of these three units, it's easiest to click Battery View so that you see all of the blank channels before you start to connect the battery wireless modules. The fronts of the wireless modules will have a FM number. That tells you the frequency that the module is communicating on to the load bank. The back side of each wireless module will tell you the battery numbers or cell numbers that will be monitored by that module. In this example, batteries 1 through 4 or cell numbers 1 through 4 will be displayed on the unit once the module is connected to the batteries. For this video, we're using a 125 volt DC string made up of 10 12 volt block batteries. Because these are 12 volt block batteries, module number 1 is going to be powered off 12 volts DC, and we're going to start by connecting the black lead to the negative post of battery number 4. In order to get the module to power up, the red lead is going to connect to the positive post of battery number 4. As soon as those two leads are connected, you'll see the LEDs, the green power light flashing, indicating that the module is powered up, and the red LED flashing, indicating that the module is communicating to the load bank. The 4 yellow leads for the wireless modules connect to the batteries in order, with the shortest yellow lead being the closest to the black lead. The next longest yellow lead goes to the positive of battery number 3. The next longest yellow lead goes to the positive of battery number 2. And the longest yellow lead goes to the main positive of the battery string. On the load bank display screen itself, you can see that the voltages for batteries number 1 through 4 appear on the display as I connect the wireless modules. So this is a good way to make sure that your wireless modules are communicating as you're connecting them to the battery string. Because we have a number of batteries that is not divisible by 4, the connection of the final module takes a special wire configuration. The black lead is going to connect to battery number 10, negative, or the main negative of the string. The red lead is going to connect to number 10, positive. You'll see that powers up the module with 12 volts. Then my shortest yellow lead is going to connect to the positive on battery number 10. My next shortest yellow lead is going to connect to the positive on battery number 9, or the same point where the negative of the previous module connects. And then my final 2 leads, because they're not being monitored, can be placed also on that number 9 positive. I'm not going to get any voltages, and I won't see anything on those channels. And when I look at the SBS-8400 display or the 200D CT display, you'll see that the voltages for number 9 and number 10 have populated. So again, to reconfirm that the modules are connected correctly on 12 volt block batteries, I have my longest yellow lead on my main positive or number 1 positive, my second longest yellow on number 2 positive, my third longest yellow on number 3 positive, my shortest yellow lead and the red lead on battery number 4 positive, and my black lead on battery number 4 negative. Connection of the second module starts with the longest yellow lead connected to the same point electrically as the black lead from the previous module. So my longest yellow lead is on positive number 5. My next longest lead is on positive of number 6. My second shortest yellow lead is on the positive of number 7. You'll see my you'll see my yellow and my red leads on the positive of number 8, and you'll see my black lead connected to the negative of battery number 8. For the final module, you see the positive on the positive of number 10, the black lead on the negative of number 10, the shortest yellow lead with the red on the positive of number 10 battery, the second longest lead on the positive of number 9 battery, and the additional free yellow leads can be connected into that point electrically. Once all the wireless modules are connected and we're ready to begin the capacity test, you'll see that the colors on the displays are green, red, and yellow. The green battery or green values indicate the highest values. The red values indicate the lowest value at that point in time, and everything in between the high and the low will be in yellow. Over the course of the test, these colors will change with respect to what the conditions of the batteries are during the discharge. The values displayed on the screen can be changed from numerical values to graphical values simply by pressing the chart button, and then you're looking at the battery voltages in a graphical format. Press the table button to return to value information. Press the exit button to go back out to your preset screen or your active test screen. When using the wireless modules on 2-volt cells for the 8400 and 200 CT, the wireless modules are powered across 4 2-volt cells, with the red lead being connected on the main positive post and the black lead being connected on the negative of cell number 4. Wireless modules are connected with the shortest lead connected closest to the black lead, measuring cell's forward voltage, and the longest yellow lead being connected with the red lead, measuring cell number 1's voltage. When connecting the second module on 2-volt cells, the longest yellow and the red land on the same intercell connector or electrical point as the black from the previous module. Again, the order is longest yellow goes with the red, next longest yellow goes on number 6 positive, the second shortest yellow goes on number 7 positive, the shortest yellow cable goes on number 8 positive, and the black goes on number 8 negative. When we get to the end of a module and an uneven number of battery cells divided by 4, we have to distort the wiring so that the negative is our reference point on the main negative of the battery. The shortest yellow is on the positive of cell number 18. The other 3 yellows are stacked with the negative on number 17 positive, and the red lead has to extend out 2 more cells to number 15 positive to give us the 8 volts necessary to power up the module. If during testing you have to jumper out a cell in the middle of 4 modules, it will reduce the power to the module by 2 volts. When I break these intercell connectors, I have to take my power supply voltage for that module and move it 1 additional intercell connector to give me the additional voltage needed to power the module back up. When using the 1.2 2-volt modules for the 200 CT or 8400, there are 5 leads. The black lead will always go on the negative post. The shortest red post will go 1 positive post in front of that, and the red leads are connected in order from the shortest to longest away from the black lead.